What do you do now? Slope. Now I'm looking at these pictures here. I see a ski slope. Here's kind of like a sliding hill. Here's a ladder, slope of a ladder, slope of a slide. This roof here, if I can get there, that has a slope. What else we got here? On these steps, you can see the railing is having a slope, a sliding slope. What do we think slope is? Kind of based on these pictures, what's another word? What's a synonym, if you will, for slope then? You know what a synonym is? Yeah, it's something with the same meaning. Do we have like, well, one word, something with the same meaning? You have one, William? Inclined plane, wow, yeah. A what? Ramp. Okay. Other words that we can think of? What? Hills. Good. Yeah, Will, you got one? No. How about some good ones yesterday? Somebody said slant. I like to think of tilt, right? So basically what we want to do is, I'm looking at this one, I love this one, the high heel shoes. So what is the slope of this? Can we quantify, which means can we assign a number that helps us describe the tilt of the line that we're seeing? And that's basically what we're going to be doing. Yep, comment? Huh? Well, we're not really measuring the degrees. We're not looking at the angle. We're just kind of, but that's, you know, it's basically this line is tilted. What number describes that tilt? Yeah.
Is it the whole, like,
well, yeah, we're going to do the lesson right now. We'll find out where it is. Okay, so slope. So slope describes the steepness. So when we were kind of looking at those pictures, steepness kind of describes a slope. Right? If you think of a hill, like a very steep hill, it's harder to walk up than a hill that's not very steep. So let's see what I got here. So in math, slope is a ratio. Do we know what a ratio is? Let's hear what a ratio is. I know you guys know this. What's a ratio? What is it? Comparing two things. And how are we comparing two things? Yeah? How do we do it? You don't remember? You're basically comparing by doing a division. Now here is one way. Now, let's see, what's the ratio of boys to girls in here? How many boys do we have? Somebody count for me. Hunter's working it. Okay, Hunter's counting the number of boys. I need somebody to count the number of girls. How many? 16 boys. 16. Whoa. Okay, how many girls? Sarah's working it. 5? How many? 7. Wow. So we have 16 boys to 7 girls. And we have 2 boys that are absent too. Wow! Who put this class together? Yeah, the girls were like, what? Well, that explains a lot, right, ladies? Yeah. Oh, okay, we got all these boys here. So one way to write that is 16 over 7. We could also write it like this. 16, remember with the little colon? We say both 16 to 7, right? What else can we do here? Now, let's say we had a different number. Let's say there were 16 and we have another girl come in. Kind of even it out. Let's pretend we have 8 girls. Would I leave the ratio written like that? How would I write this ratio? Yeah, so you basically have to reduce the fraction. Now and this shows 2 to 1, you can also write this as 2. The ratio is a number. It's a number. And we have to kind of understand that it's telling us something. So if you tell me 2 is a ratio, it's understood it's 2 to 1. We kind of have to understand that. So ratio is what we use for a slope. And what is the ratio of? It's a height versus a width. A vertical, which is up and down, as compared to a horizontal. And we'll look at some examples of that in a moment. Like this one. And why is there stuff written on here? Oh, I know what happened. No, I used this one by accident. If you guys did yesterday was a tough day. I'm going to tell you that. All right, let's do this. Okay. So this is a roller coaster. Anybody like roller coasters? We're the crazy people. Where are you? Okay. We love this. We love theory. We're going to just die. We love that. it fall straight down? Use a little bit of physics, right gravity will pull it straight down. And it would go 56 feet. So that's how high you are at the highest point. And then we measure how wide is a horizontal distance. So in this roller coaster, it's 56 feet high and it's 42 feet wide. So when I measure this slope to kind of find the number for it, I take a ratio of the height to the width. So what do I get here? 56 feet. That's the height. And I relate it, 42 feet. I'm going to eventually someday get used to this little slate, but it may not be today. So here it is. Now, remember, if you have a ratio and you have the same units, what happens to those units? No dimensional analysis here. What happens to feet and feet? They go away. Why do they go away? They do. It's kind of like a variable. They cancel each other out. When you have the same units, I really don't need units. Because it's basically saying this one is so many times bigger than that one. Now, can I leave my ratio like this? No. So how can I reduce this thing? You see any common factors? 2? All right, so what do I get here? Looks like 28 over, 21. Am I done reducing? No. I have another common factor, right? 4 to 3. That is supposed to be a 4. So 4 to 3. So what does that mean? For every 4 units of height, there's 3 units of width. So, whoops, I'm trying to get over here, see if I can do it. 4 units of height, 3 units of width. 4 units of height, 3 units of width. And that's how I define the slope. So this slope is 4 over 3. Now let's say I come to the next hill on this coaster, and it's got the same width here, but it's actually 14 feet higher than this. Oh. So how high now is the next hill? 70 feet. Right, we add the 56 plus the 14, and we get 70 feet over the same 42 feet. Now can we reduce this thing? We see 2 right away, right? So we can say that's 35 over 21, which is, again, you see 7 works in both. 5 over 3? Okay. Now think about this. Which hill do you like better if you love roller coasters? The higher one. So which is the higher one? The first one or the second one? Second one. So what happened to my slope, my hill, when I raised the height but I didn't change the width? That's deeper. So let's look at the numbers here. Which number is bigger? 4/3 or 5/3? Let's say this is pi and you love pi. Would you rather have 4/3 of pi, which is more than 1 pi, or 5/3 of pi? 5/3 of pi. Yeah, right. 5/3 is a bigger number. You have 5/3. So as the slope gets bigger, that's telling us the tilt is bigger. So that's how these numbers are working for us. So that will change that for us. So let's see what else we're doing here. Slope is a ratio. It's the vertical change to the horizontal change. Now this can be a little confusing sometimes. So I'm looking at these 2 points here. Let's just look at this diagram. This one says x1, y1. This one says x2, y2. What does that mean? What? Well, no, I just want to know, what do these little, what's the notation you're telling me? Yeah. Right, so it's generalizing. You have a line, you have 2 points on the line. This is the first x, the first y for the first point, and a second x and a second y for the second point. Now, did I have to call them this? Could I have called this one x1, y1, and this one x2, y2? I could have. Yeah, it's arbitrary, but we're just saying, in general, here's how it works. Now, I know I have to find a height. So the height between these 2 points, if you look at the y2 and you look at the y1, how do you get that? Let's pretend that the height of this one, the y value is 8, and let's say that the height of this one was 3. If I could draw that would. Let's work it out. Okay, 3. All right, so was 6. So what's the distance this way? 4. How am I getting it? I'm subtracting. So the way we get a height is we subtract the y's, and the way we get a width is we subtract the x's. Now we use these words rise over run. Rise is just another way that people think is easier to remember than vertical, because rise goes up, right? When you rise, you go up. So that's a vertical change. And when you run this way. Most of us do. So rise over 1 is just a way to remember vertical over horizontal. Vertical over horizontal. Important. Vertical change is the difference between the y values, and horizontal change is the difference between the x values. And this will become important in just 1 second. Okay, so what else do we know here? I think the powers that be got together and said, we need a letter to mean slope, and what's the most confusing one we can think of? How about S for slope? No, too obvious. Okay, well, how about M? I like it, because I see no reason why slope should have an M. So we're calling it M. So whenever you see an M, we're talking about slope. I have no idea why. I Googled this. What? It must mean something. I haven't been able to find it. I've heard people make stuff up. I don't know, but it's M. So if you see M equals, I want to know slope. Slope. M and slope. It looks like hills? Okay. I'll take that. He said, that's as good as any reason. Because it looks like hills, and hills have slope. All right. Find the slope by creating the ratio of the rise over run. The change in the y over the change in the x's. And the way you do that is you find 2 points. The rise is the difference in the y values. The run is the difference in the x values. And I'm throwing in my ordinate abscissa words. Remember those words? The ordinate is the y value of an x right there. Or the abscissa is the x value. And here it comes. You ready for the formula? You ready? Okay, here's the slope formula. It's what we just talked about. Slope, which is using this big M. It's the change in the y over the change in the x. Subtract the y's, subtract the x's. So if you have 2 points, x1, y1, and x2, y2, subtract the y's, subtract the x's. Now look at this little funny notation here. See these equal signs? They all mean the same thing. This triangle, is a Greek letter. More Greek! Yay! It's a Greek letter. This one is delta. Delta. And delta, I like to think of delta as difference. They both start with D. Delta and difference. Take the difference of the y's, divide by the difference in the x's. It's shorthand. And believe me, this comes in handy sometimes. For now, I would like you writing out the whole formula until it's kind of etched in your brain. But eventually it'll go here, and it's much faster and easier to kind of write it. Yeah?
Oh wait, so the workbook that says that probably have y2 and
Look at this girl, very observant. Did you see this on the warm-up?
Oh, yeah.
Absolutely. And you guys were able to use it. You were finding slope, you didn't even know it. That's kind of awesome. This next point here, I think is here, is actually very, very important. Can you find it on your notes? Who can find this bullet? If I could steer this thing. The slope will calculate the same value for any 2 points on a line. Find it on your notes. The bullet near the top. You find it? Yeah, circle it and put a little star. And this is kind of important, exclamation point. So if you have a line, you can pick any 2 points on that line and you will get the same slope. Because a line has a slope assigned to it. For between any x and any y, that change in y, change in x is the same. Any 2 points on a line will give you the same slope ratio. You find it, circle it, starring it, he's doing it. I like that. Excellent. Okay, so now let's look at an example. How does this work? So you may get a question like this, or you may want to know. I've got 2 xy pairs. If I were to connect these, I'd get a line, right? So they want to know, what's the slope of the line that if you connect these 2 points, what's that slope? So I'm just going to use this formula. M equals y2 minus y1 over x2 minus x1. So I have to identify. what's my x1? And what's my y1? Right, over here. And then what's my x2? And 6. So basically, what did I do? Here's the first pair. Here's the second pair. That's supposed to be 2. Then I plug it into the formula. So y2 minus y1. 6 minus 2 over x2 minus x1. Now we're careful. Minus. But look at that. It's a negative number, isn't it? So we're being really, really, really careful. So 6 minus 2, let's see, what's that? That's 4. Over, now what's a negative negative? So 2 plus 4. That's 6. Can I leave a ratio like that? So what does that become? So this says the slope of this line right here is 2/3. The change in y over the change in x. And let's see how that works. It says if you have a horizontal change of 2, so I'm counting boxes here, what's my horizontal change? Sorry, my vertical change is 2. My horizontal change is how many boxes? 3. My vertical change is 2. My horizontal change is 3. So can we see how that slope works? Down to left, to down to left. I'm showing that is the change. For every 2 changes in vertical, there's 3 changes in horizontal. So you can actually figure out slope by looking at the line and counting the boxes. So watch this. I find 2 points. And notice the points I pick is like an exact integer pair. Right? The points here are integers. It's right on a crosshair. So when I go down to get it, I go down 2. I go left 3, 2/3. So you can actually kind of find these numbers just looking at boxes. I want you to actually try these 2. See if you can do these 2 things on your own, just using that slope formula. And let's see how we're doing. Some of you work really quickly and have this already. I got, for the second one, I got a slope of -2, and for the third one, a slope of 0. Did we get that? All right, and 0 over 2, what is that? What is 0 over 2 in simplest form? And would it be 0 over 2? It would be 0 over 6, wouldn't it? 4 minus -2. Minus, minus. Yeah, so you got to be so careful with those minuses. You're subtracting. But even so, what is 0 over 6? What is it? All right, well, let's just finish this one. All answers have to be in simplest form. 0 over 6. If you have 0, 6, how many 6s do you have? 0, right? So we should say 0. B, you had a question on? So you get 5 minus -1. What am I doing here? Besides it being way upside down, over 3 minus 6. So what did I do? I actually did y1 minus y2 over x1 minus x2. Can I do that? Does it matter if I go y2 minus y1 or if I go y1 minus y2? No. It doesn't matter. What can't you do? You can't go this way for the first one and then go the other way for the second one. So always go in the same order. So what is 5 minus -1? 6. Minus, minus. I'm having a little trouble here. 3 minus 6? -3. What's 6 divided by -3? -2. Other questions? Because really, this is all there is to finding slope. That's it. So, yeah.
Wait, I thought you always have to do y2 minus y1 and x2 minus something.
Yeah, that's what the formula says. But you know what? Isn't it kind of arbitrary? Who's y1 and who's y2? It kind of is. I just chose this one to be x1, y1, and this one to be y2, y1. Could I have gone the other way?
Wait, you can't
So
do
you,
one.
as long as, Erin, as long as you subtract in the same order, this way and then this way, you can do it either way. You subtract in the same order, it goes either way. It works. Try it. Try both ways. What is y2 minus y1? -1 minus 5 is -6. Over 6 minus 3 is 3. What's -6 divided by 3? -2. As long as you do them, subtract in the same order, it does y's, which is a common mistake. You just kind of feel like it. It's the difference of the y's over the difference of the x's. Yes. Yeah.
Should you simplify the -6 over 3 like 3?
What is -6 over 3? Now remember, you're just dividing. Fractions are division, so you just divide. -6 divided by 3. All right, good. These are all good questions. Let's see what else we got here. Other things to know about slope. We can tell just by looking at a line what kind of slope it is in terms of positive, negative, or some other thing. Now this is a positive slope. How do I know? Now always be traveling left to right here. I'm working my way up towards the bigger numbers, and I start going uphill, right? If you increase, this is called a positive slope. And I kind of remember this. If you're going up, you're a positive person, because up people are positive. So this is positive slope. So this guy over here, if I can click on it, he is a negative slope. Again, going left to right, what's happening here? Oh, down people are negative, right? We're going down. So this is positive. If you're going up, you're positive. If you're going down, you're negative. Somebody showed me this trick. I had never noticed it before. I can actually, if I can make this pen move, make an N out of this. Yeah, I can make an N out of that one. The negative one. So that's the negative one. But going up positive, going down negative. We also have slopes like this that are neither positive nor negative. They're not going up, they're not going down. Wow, what kind of slope is this? Well, I need a number. Why is this one 0? You know, what's the tilt? What's the steepness on this thing? I'm walking on a 0 slope, at least I hope I am. Right? Am I going uphill or downhill right now? No? What is the tilt on the floor? We hope. 0. So this one is 0. Now you can use the slope formula. Let's try subtracting the y values. The reds, right? That's 4 minus 4. Now let's subtract the blues. 4 minus -2. That's plus 2. And I'm getting 0 over 6, which is 0. So you can use the points. You can use 2 points and use the formula, but this should be one we recognize. There's no tilt, 0 slope. Now what about something like this? This one's crazy. What's the tilt on this? Can I get any more tilting? I can't. This is about, this I would have to assign the biggest number there is to say how tilty that one is. This one I can see there's no tilt. This is the utmost tilt that we can get. But I can walk on this. Can I walk on this one? Oh, right. There's a big splat of this greaser on the bottom of this one. I can't walk on that one. I can't do it. And what is the biggest number? 5's the biggest number? What's the biggest number? Yeah, I wish infinity was a number. Infinity is not a number. I don't have a biggest number. So I can't, you know what I say? This is an undefined slope. If I could write it, I would. Since I'm writing the word undefined, you can't read it because I'm not used to this little slate. Undefined, undefined. Now let's use the slope formula. Right, subtract the y's, 5 minus 1. And then subtract the x's, 3 minus 3. What do I get? 4 over what? 0? Oh, I can barely look at that thing. 4 over 0? What do I know about dividing by 0? We can't. Wait, what? We get a black hole? What'd you say? I can't divide by 0. Try it on your calculator. 4 divided by 0, what happens? I hope it doesn't blow up. It might. It might. My smoke might start coming out. It says error, divide by 0, right? You cannot divide by 0 in math. Because that says, think about it, 4 over 0, you think, I don't know, maybe that's 4. What's 4 times 0? It's not 4, right? When you multiply those numbers, you should get back. Anything times 0 is 0. I'm never going to get 4. So I can't do this. So if I were to ask you, what's the slope of this line, what are you going to say? It's an undefined slope. I can't even tell you what it is. Undefined. Because we can't divide by 0. There is no biggest number to define that. So let's see if we got this now. So we're going to look at a few of them. What kind of slope? Is this positive, negative, 0, or undefined? Negative. I heard both things. It is negative. Why is it negative? Going down. And you can kind of see that little end in there. What's going on here? Positive going up. What's So what we get for that first slope?
Let's see. 10 minus 4 over 8 minus 5. Is that right? Okay, 6 over 3, 2. So this slope, this says that for every vertical change of 2, there's one horizontal change. So now, do we pick two different points? What points did you pick? What'd you pick? Yeah? Okay, skip one. All right, so let's see here. So I have to do 28 minus 16, right? Change in y. Oh, change in x. 17 minus 11? What's 28 minus 16? What's 17 minus 11? Which is? See? How cool is that? Now, if you didn't get the same thing, there's a mistake someplace. Common mistakes that I often see, just so you're kind of aware of it so you don't do it, is very often people want to put the x's on top and the y's on the bottom. That's very natural, right? We're used to x coming first and y coming second. So this is, you got to kind of love a little concentrated thing. No. Once again, let's see how confusing can we make this. Yeah, let's have y come first. So y's are in the numerator and the x's are in the denominator. Okay? So if you got 1/2, you did it backwards. Anybody get 1/2? Yeah, you believe me or you don't. You're just not saying. All right, so that's how we find slope, easy. I'm skipping this one for now. I want you to go to the U-tries. The bonus is an optional one, but I would like you to do A, B, and C. Find the slope in simplest form. Simplest form. All right, I'm just going to put up answers, see how we're doing so you can compare what you got at least so far. What do you think? Do you agree, disagree? Want to do one? I can. Oh, right now? Yeah. My pen's gone. Excuse me. Okay. So B. Here we go. So let's see. It's y2 minus y1. So this one minus that one. Let's try that. -5 minus -1. See how careful you got to be with those negatives? Oh, we're going that same direction with the x's now. Whoops. 6 minus 4. Well, a negative is a plus. -5 plus what? Okay. And 6 minus 4. Well, what's -4 over 2? Because I have to put it in simplest form. Oh. Right? Yes. See? Which points did you use? I'm going to use the first two. How's that? Yeah. And you know, once they're in the table, look at this. And they're right one on top of the other. 8 minus 5 is 3. -7 minus -2. So that's -7 plus 2. -5. Now, do we all get that 3 over -5 is the same as a -3 over 5? Do we know that? Do we? Do we not know that? We know that that's the same as -3 over 5? That these are all the same thing? Because what's a positive divided by a negative? It's a negative, right? Negative divided by positive, it's a negative. So this is a negative 3/5. Either one of these is correct. You could have, but it's a slope. It's a negative, this number, negative 3/5. There's my slope. So that means I don't know a lot about it, but I know it goes down. I know this one goes down, and I know this one goes up, right? Just because of the slope. This is a positive slope, a negative slope, a negative slope. Yeah, it's kind of cool stuff. All right, let's look at kind of the next thing here, which is rate of change. Now, rate of change is why we learn about slope. Rate of change is using slope in real life. We use this all the time. We do? No, we don't. Yes, we do. A rate of change compares a change in one quantity to a change in another. Well, what is slope? Slope is the rate of change comparing a vertical to a horizontal. Slope is a rate of change. It is. What else we got here? We can compare and graph real world data. Now, just as when you're working these, time is often a real world kind of issue, real factor in it. So time is always an independent variable variables are our x's, our input. So time is always an input, and what I mean by that is it's an x value. And we'll see what this means when we look at some of these. So here's an example, real world problem. A person walks for exercise, and they're a very consistent walker. So 30 minutes, they go 1.5 miles. 60 minutes, they go 3 miles. 90 minutes, they go 4.5 miles. They're always kind of going their same rate. But what is that rate? What is the rate of change in distance with respect to time? So I don't see x, y anymore, but I see distance with respect to time. So when I use the units, it helps me figure out what I'm doing here. Because I can compare this with change in y over change in x. And I really should write this as change in distance over change in time. So now I'm looking at things that we're not necessarily calling x and y, but they're acting like our x and y. Time is always the x, the input. So when I look at this table, it's like this is the x and this is the y. So when I know that, can I find what I need to find here? I want the rate of change of distance. So this is just like a table like we did before. I'm going to use, I guess I'll use 2 points. 3 minus 1.5 over 60 minus 30. And if this is just a slope problem. So 3 minus 1.5 is 1.5. 60 minus 30 is 30. Well, they kind of started it. They made it in decimals. We can keep it in decimal. Because real life problems we often do in decimal. Somebody can get your calculator. What is 1.5 divided by 30? 0.5. Now, units should really go up here. What is my distance here? It's miles. And what are my minutes? So he goes 0.05 miles per minute. I found the velocity, right? I found the speed that this person is going based on what? That's pretty good walk. It's not bad. It's not bad. Let's look at another one. This one, I like this one. This tells a little story. This is community theater, and they're recording attendance to the play that they're putting on. So this is weeks. So again, time is my x, and then this is the people who came. So between weeks 1 and 4, what happened to the attendance? What kind of slope do I see? How's this slope, right? It went up. That's good, right? You're putting on a play, don't you want your attendance to go up? Now, what happened between week 4 and 6? Well, we don't know why yet, but we know that the attendance was down. And then what happened between 6 and 10, week 6 and 10? Yeah, it went down, but Rachel, she had, what else can you say? She made a little, like, sinker motion. What happened here? This went down, this went down. Who went down worse? Right? It's a steeper line. So the attendance went down faster during this third period that we're looking at than it did here. And does it kind of make sense? It's a community theater, new play, a lot of people go. Start slacking off a little bit because maybe, like we said, maybe enough people have seen it, and then it gets a more dramatic shift off, and then we close it. Now, if this had been Broadway, if Broadway was seeing this kind of attendance, what would they do? They'd probably close the play. It's so much money to run a Broadway show if they don't get a certain amount of attendance. They have to do that. Now, I don't know if you guys watch certain TV shows. I'm trying to think. Maybe Mad Men does this, where they'll put up a chart for sales, right? Sales, look at our sales. Would this be good if this was your sales chart?
The beginning would be good.
The beginning would be great. Well, then what? This might be like the sale of record players. Like, okay, here's 1985. Yeah, and then it like stops, right? We don't have that anymore. So these kinds of graphs with slopes are very, very helpful in business. So I'm going to kind of skip the rest of this. It's basically finding what are the slope numbers, and you use that by subtracting y's, subtracting x's. I can find the actual slope, but do I even really need to tell the story here? I don't. I don't even need the real slopes. So that's another example, real life using the slope. Ooh, okay, we've got a missile. Who's ready for rocket science? Who's a rocket scientist? Every hand, there you go. So a missile is 2 miles above the Earth in 60 seconds after launch, and 60 miles above the Earth in 3 minutes. What's the rate of change in miles per minute? So they're giving me the units, and I like to do this. Because if I see miles per minute, it's going to help me decide, well, who's my input, who's my output?
miles to my change in minutes with what I know about slope, change in y over change in x. Because basically, the way you do these problems is I'm going to look for 2 points. 2 points, and then when I have them, I'm going to use the slope formula. That's how you get rate of change, slope formula. So let's see, here's one kind of set of numbers, 2 miles in 60 seconds, and 6 miles in 3 minutes. Now my question is here, okay, so 2 and 60 go together, but which is the input and which is the output? Who's the x and who's the y? What do you think? Time is always a yes. I'm putting units here, I'm trying to anyway. 60 seconds for 2 miles. And also, look here, change in y, do we say miles per minute or minutes per mile? Miles per minute. So if you compare that with change in y and change in x, we can see x is minutes and y is miles. So setting up your units also tells. So same thing here, 3 minutes goes with 6 miles. So can I go ahead now and find slope? I got one little problem. What's my one little problem that I still have here? Yeah, what is it, Brian? Yeah, I've got seconds, I've got minutes. Right? They need to match. So we either turn one into seconds and one into minutes. What do you think? Which way, Kelly? Turn into seconds? Okay, so how do I do that? How do I turn 3 minutes into seconds? So 180 seconds. Right? What was my other option? How would I turn 60 seconds into minutes? Divide by 60. So what do I get? 1 minute. So I have an option. I can work with seconds or I can work with minutes. In this case, the minutes came out nice. Sometimes they don't. You're absolutely right. And I'm looking at my answer here. So which way maybe you want to go? Maybe work with the minutes. But you can do it either way. Right? You can do it either way. So I'm going to take my difference in y's. I've got 6 minus 2 miles over, now work with the minutes, 3 minus 1 minutes. Now you could have done this with seconds, and then you just have to convert at the end. So I've got 4 miles over 2 minutes, which is 2 miles per minute, which is actually not terribly fast for a missile. I don't know how successful this launch will be. I think it's going to turn around. Yeah, it's not very fast. I think they go a little faster usually. Yeah, but that's it. I have figured out, you are rocket scientists, friends. Look what you did. We figured out the velocity of this missile. Yeah, that's pretty cool. Okay, let's see. You try. So there's 4 of these, work with slope, and then I've got 2 of these guys. So you want to kind of play with those rate of change as well. So go ahead and work. I'm going to go ahead and put the answers up to this one. A, B, C, D. How do you do?
Zero for B.
Is 0 the same as undefined?
Oh, yeah, is it for?
Is 0 the same as undefined? No. Undefined is undefined. 0 is defined. 0 is 0. Right? So if you're doing B, you did like 9 minus 6 over negative 1 minus negative 1, right? You got 3 over 0. If you left me this, you are incorrect. Why are you incorrect? If you said, here, is this a number? Is this even a valid number to express in math? No, you should almost be like, ah! It is an undefined slope. What does this one actually look like? Straight up and down. It's meant to be straight up and down, right? So yes, yes. For which one? It looks like we've mixed up our negatives probably. Negative 5 minus negative 3 over, whoops, 1 minus 4.
That's like 8 over
So negative 5 plus 3. 1 minus 4. What's a negative over a negative? Positive. And then, if you left me with negative 2 over negative 3, I'm marking it wrong. Why am I marking that wrong? Not simplify form. Simplify it. A negative over negative. That's a positive number. Show me a positive number. What else? What else on this page? Did anybody here put 0 over 8? Or 0 over a negative 8? Why is this wrong? We did not simplify it. If you have 0 8s, you have 0. Alright? Yes, yes. calories over change in time. Because again, think about what you would say. Would you say, well, let's see, I burn 20 calories a minute or 10 minutes per calorie? Like, what would you say? You'd say calories per minute, right? So calories over time. So who's my X? Time. So you pick 2 points. You get to choose which. And the time goes in the X. And the calories go, whoops. So, and again, you work out what you get here. And 12.5 calories per minute. All right, and then we go back to this guy. This guy, he started savings account with $100. After 5 weeks, he had $150. After 10 weeks, he had $200. Rate of change of money. Now, so here I've got money, and I've got time, I've got weeks. Did we say dollars per week or weeks per dollar?
Dollars per week.
So it's change in dollars, whoops, over change per week. So when I try and build my XY pairs, I have 5 weeks and $150 go together. So what's the pair? Is it 5, 150 or 150, 5? Which is it? Now remember, here's like your Y, and this is your X. So the weeks are the X. 5 weeks by $150. What about the 10 weeks? Well, the 10 comes first. 200. So now I can say it's 200 minus $150 over 10 minus 5 weeks. So it's a $50 for 5 weeks, which is the same as $10 for 1 week. So $10 per week. Right? That what we got? That's what I got. Questions?